Hello students, myself Purnima M from the Department of Mathematics, SJB Institute of Technology. In this video, let us understand some topics of polar curves. Here, let us discuss about polar curves basically and let us derive the angle between radius vector and tangent. First, let us know what is the difference between Cartesian curve and polar curve. When the equation containing Cartesian coordinates like x, y in two dimension, that equation is called Cartesian curve. The equation containing polar coordinates r theta is called polar curve. Why the studying polar curves is important? Sometimes in an engineering application problem, when you are finding area, volume, surface area, all, we find integration is difficult. So in such a situation, converting Cartesian coordinate to the polar coordinate, we can make simple procedure for integration and we can solve it easily. Now let's understand what is polar coordinate system and what are the terms r and theta represent here. So we have here the point p r comma theta, so containing polar coordinates. So here O is represent in the Cartesian coordinate system, we call O is a origin. In polar coordinate system we call O is a pole, and x-axis we call initial line, and the line OP, if you join the line from the origin or pole to the point P r comma theta, that is we call radial distance, and also we call radius vector denoted by the term r. Next, let us take this length is x and this length is y. Okay, then OP is equal to r. Theta is angle made by the line OP with the positive x-axis. Then this r and theta is polar coordinates of the point. Next we see that what is the relation between Cartesian coordinates x, y and the polar coordinates r theta. So we know that already what is theta, what is r represent. R is a radius vector, theta is the angle inclined between the radius vector and the initial line. Okay, so this is the distance y, this is the distance x. From this diagram, you can write the cos theta is what? Adjacent divided by hypotenuse. So what is adjacent of this? X. Divided by hypotenuse is r. So you can write from this x is equal to r cos theta. Similarly, you can write sin theta is opposite divided by hypotenuse from the right angle triangle. So opposite is what? Y. Hypotenuse r. So from this we can write y is equal to r sin theta. So when you are solving application problem, if you are finding difficult in terms of coordinates x and y, we can transform x and y in terms of r and theta using this substitution. So this helps lot when you are doing integration procedure. Also, by squaring both the side of the equation 1 and equation 2, we get x square plus y square. Other side r square cos square theta plus r square sin square theta. Then if you take r square common out, cos square theta plus sin square theta remaining will become 1. So we have what? R square is equal to x square plus y square. From that you can easily write r is equal to square root of x square plus y square. And also if you divide y divided by x, if you divide 2 divided by 1, so we get y by x is equal to r gets cancelled, sin theta by cos theta is tan theta. So when tan theta is equal to y by x, theta can be written as tan inverse y by x. So these converts polar coordinates to Cartesian coordinates. Now let's see how to obtain the angle between radius vector and the tangent, and it is very important derivation. You can expect this derivation in the exam. So how they'll ask? Question format with the usual notation, prove that tan phi is equal to r d theta by dr. Okay, to understand this derivation, we have to draw a rough diagram. Draw a curve and let us mark a point P r theta, where r is the radius vector. Then you can take this as radius vector from the origin to the point. And you can write the angle theta here. So therefore OP is equal to the letter R, radius vector. Then we draw a tangent. At P with a positive x-axis. So let us take, this is the point T. So where the tangent makes an angle psi with a positive x-axis. So now you can note that angle between the radius vector and the tangent. So angle between the radius vector, this is the radius vector, and the tangent, this can be written as phi. So now from the diagram you can say that psi is the outer angle, means exterior angle. It is equal to sum of opposite interior angles. So you can write that psi is equal to theta plus phi. Also the slope of the tangent is tan psi, and you can write this as dy by dx. So you can write that dy by dx can be written as tan psi, that can be written as theta plus phi. And using the identity tan A plus B can be expanded as tan theta plus tan phi divide by 1 minus tan theta into tan phi. So let us take this result is 1. Also we have relation between Cartesian and polar coordinates are, we have that x is equal to r cos theta, y is equal to r sin theta. So if you differentiate x and y with respect to theta, treating r as a function of theta, we get as dx by d theta. We apply the product rule. Dr by d theta, keep cos theta as it is, and keeping r as it is, differentiation of cos theta is minus sin theta. Similarly, dy by d theta, applying product rule, differentiation of r is dr by d theta, keep sin theta as it is, and keeping r as it is, differentiation of sin theta is cos theta. And you can write dy by dx as, using these two, it is dy by d theta divided by dx by d theta. And substituting the above result, it is dr by d theta sin theta plus r cos theta divided by dr by d theta cos theta minus r sin theta. Now, so let us concentrate on the term first in the numerator. So entirely I have to get this as tan theta to compare with the result 1 we have here. To compare with the result 1. So I have to get this as a tan theta. I should divide by dr by d theta and also cos theta. So what I'll do now? So we divide both numerator and denominator of RHS by dr by d theta into cos theta. So my aim is getting it is a tan theta. Therefore I get dy by dx. The left. So if you divide this by dr by d theta cos theta, this gets cancelled. So sin theta by cos theta can be written as tan theta. And what happened in the other second term, r cos theta gets cancelled, r divided by dr by d theta, that can be written as r d theta by dr. And divide by, we have here the same what you are dividing, so it become here 1 minus, again sin theta by cos theta is a tan theta, and r divided by dr by d theta can be written as r d theta by dr. So let me take this is the result 2. Now our LHS of 1 and 2 are same as dy by dx. Now we compare or equate RHS of 1 and 2. So what we have RHS of 1, it is a tan theta plus tan phi divided by 1 minus tan theta into tan phi. So RHS of 2 is tan theta plus r d theta by dr divided by 1 minus r d theta by dr tan theta. So now equating both the side. So in the place of tan theta is there. So you can observe that in the place of tan phi, we have r d theta by dr in both numerator and denominator. So you can conclude that the result is tan phi is r d theta by dr. So using this result, you can obtain the angle between radius vector and the tangent phi.